Welcome to this tutorial on Jump software.
In this video, we'll talk about 5 measures of central tendency, which are your mean, median mode, geometric mean, harmonic mean, and importance of each of these by taking an example. So let's get started. So before we move ahead, I have a question for you. Let's say you are in charge of a quality assurance process of a company and you have inspected about 10 different batches. And these are the samples that you see in each of the batches. So you have like 200 in odd number batches and 400 in even number batches. And third column of the table that you see on the screen talks about the number of defects in each of those batches. For example, in batch 1, out of 200 samples that you got, 12 of them are defective. And in batch number 10, out of 400 samples that you have, you got about 10 defective pieces. Now, if you have to summarize this data, so do you think by using mean would be enough? So if I take average of all the defect 4 batches, so we get about 13.4 per batch. Do you think this is the right way to summarize this data? So let's get started. We'll take some examples and we'll see that probably saying 13.4 per batches may not be a good idea, because now if they had almost similar sample, then we could have said about 13.4 defects per batch. But you can clearly see that some samples have 200 numbers and some has 400. So it would be better if we say per 100 sample rather than per batch. So let's understand different metric and we'll try to put those metric in a business context. We're talking about measure of central tendency. It's a statistical measure or a value that describes or summarizes the entire set of your data by identifying the central position within the data set. We have already seen what central tendency is, and we have already seen these metric. We have seen what is mean, median, mode. There are two new things which are introducing here. These are your geometric mean and harmonic mean. Now, these are also part of your mean. And the normal mean that we have studied so far is called arithmetic mean. So we'll see how geometric mean and harmonic mean are different than your arithmetic mean. So sometimes you might have to use geometric or harmonic, and normal or arithmetic mean may not work. So formula is given here. In geometric mean, we multiply all the elements and we do this root of the number of elements. So in the example here, you see you have n elements. So we perform nth root of the multiplication of all the values. Harmonic mean is sum of the reciprocal values and their average we take, and then again we perform reciprocal. That's called harmonic mean. And we'll see the characteristics and features of each of these metrics. So the first question I have on your screen is, let's say you are in charge of production plant, and you see that these are the numbers for last 10 days. So on first day, you produce about 120 product, 100 on second day, so on. And the last day, you have about 90 products. So if you have to summarize this, if you have to present to your management, you will say that we make about 98 products per day, which kind of makes sense. Now let's look at another case here. Now let's say you are managing call center of a company, and these are the number of complaints that you have received per day for last 10 days. You see on 6th day, probably you have high number of complaints, unusually high number on 6th day. Mostly you have about 35 to 80. That's the range of complaints that you get. But on one particular day, you have about 200 complaints. Now, this could be because of maybe your server was down, or you launched a new patch of new upgrade, and which created a lot of problem with your customer. So now if you take average of these values and you try to calculate, you get about 72.5 complaints per day. Now, if you have to report this number to your management, will you go ahead and say 72.5 complaints per day? If you go ahead, so remember, when you talk about average, people start making some assumptions. So when I say 72.5, I'll make that, okay, you're getting about 60 to 80 complaints or 90 complaints per day, which is probably not right. You mostly are getting 70 or 40. So the 72.5 complaints per day is very close to your second highest. So your average is equal to second highest. Now, in this case, 199 is an outlier. Now, if you include the outlier values in your analysis, your data is going to be skewed towards one end. In this case, since we have added a higher value, our data is skewed towards right side. So in this case, we should not actually take this. You can say that on average, our customer complaint is whatever, take the value minus 199, calculate the average. So you'll say the value is so much. And one day, we are in an exceptional day when we got 199 complaints. So in such case, your mean will fail. When you have outliers in your data, mean is not going to give a good picture. So on such events, we actually use median. So see here, we arrange the data in increasing order and then we take median. In this case is average of 60s. So we have 260, so we'll take average, which again becomes 60. So the right way to report this data is using median. Let's take another example. So you want to set up your own ice cream manufacturing plant, and you want to understand the flavors most liked by the people. Now, when you're setting up your own plant, you cannot start producing 10, 20 flavors on day one. You want to first understand the market. You'll start with one flavor and see how market responds to your marketing effort, to your product itself, and then you can slowly increase your product base. So now if you have to select one, generally we'll select one which has more demand in the market. So when you want to find the most liked, so you I have a research here, and the research says that most of the people like vanilla, and chocolate flavor is close behind, but all the other flavors are not as close to vanilla and chocolate. So in this case, makes more sense for you to start with vanilla ice cream, or you can start with vanilla and chocolate, or only chocolate. Both are top choice by the people. So what have we done here? We have actually calculated mode of the data. So this is how mode is used. Another example we'll see is that, let's say your friend is running a shoe store and your friend is facing some problem in terms of running the store. He has hired you to help the store to deal with the dead stock. So there are a lot of dead stocks. Dead stocks are the inventory or the stocks which are not selling more. Because of that, your stocks starts piling up. So, you have a lot of stock, but it's not going. So you've been hired and you are asked to help the store guy. So where do you start with? Shoes comes in various sizes. So I want to see how many sales you make per day for each shoe size. And then you create a table as shown on your screen. So here you see the shoe size 4, you sell only 2 per day. Whereas 6, 7, 8, you sell about 32 to 33. And then 9 and 10, again, you sell about 10 and 25 respectively. So in this case, you can clearly see that your shoe size 6, 7, 8 have a higher sales, and your 5 and 9 and 4 probably not so much. So what recommendation can you give to your friend? You say that keep more stock of 6, 7, 8, keep average number of stock for 10, and keep less stock for 4, 5, 9. So this is again an example of mode. So since the mode of this data is 8, and you can include 6 and 7 as well, since they are closer to 8 in terms of number of units that we sell. So it's better that we select 6, 7, 8 mode, and we say that these are the sizes that you should be carrying more of, and the other sizes you should carry less of. There's another example of using mode in your business. So we have seen 3 metric, mean, median, mode. We have seen how data is distributed. In mean is used when data is not skewed. Data is not distributed uneven. So mean makes more sense when your data is evenly distributed, not skewed. But when median can be used even for data is skewed or has extremely high or low values. Mode is also not impacted by extremely high or low values because we only look at the maximum occurring. So mostly your outliers values will not be the most occurring values. They will be one of or two of cases. So mode is also not impacted. Mean, we use all data to calculate, but median and mode, we don't use all the data. Median we only use to see which is the mid value based on the number of elements, and only those mid values are used. Mode, again, we look at the maximum occurring, and that only one value is used. It doesn't matter what you have other than that. So weightage, mean, we give equal weightage to all the points. In median, we only give equal weightage to the central values, and we give weightage only to the most frequently values. Others have no weightage when calculating mode. So do we have more such cases? Yes, of course. We will look at one each cases where geometric mean and harmonic mean will make more sense than your arithmetic mean. So let's look at an investment case study. So let's say you have about $100 and you want to invest in some mutual fund. Now, end of first year, you see that your value reduced to $78.9. That means you have lost about 21% there. In second year, your stock does well and you gain about 27%, which will bring your investment to about $100.68. And similarly, in third year, again, you make about 10% and your net value is 111.65. Fourth year, you make 5.9%, and final year, you make 14.5%. So end of fifth year, your $100 has become $135.38. Now, if I ask you, what is the average return? So our intuition is that, okay, you take those average values, add them together and divide by number of elements. Basically, you are taking average of the averages. You get 135.38, which is your last element, and divide by 5 because after 5 years shows that you got about 27.08 percentage return. Is this correct? Answer is that it's not correct. The amount that you have received per year, if you take average value of 27%, is not same as the average growth rate. So if you take the average of these values, it comes to 7.56. Now, if I increase my returns for 7.56 every year, I should be getting 135. Let's see. So if I keep on increasing my return by 7.56, my 100 becomes 107, then 115, so on, and you would get 143.96. So if your average return was 7.56, you should have got 143.96. Obviously, we got less than 143. That means our net return is not 7.56, but much less than that. So this is an example where your arithmetic means fail. When you're talking about the mean itself, you're talking about the averages, then arithmetic mean fails, and we need to bring in what is called a geometric mean. So in geometric mean, you get that return for every year, you multiply that. So if you look at the value here after end of first year, it is 0.789. End of second year, it is 1.276. Now you multiply these values, 0.789 into 1.276 into 1.1 into 1.059 into 1.145, and you take a fifth root because we have 5 years, 5 number of elements we have. So it will give you about 135. So this gives you about 6.25. Geometric mean of this data will be 0.0625, which means about 6.25 percentage. Now, if you want to calculate whether 6.25 is correct or not, you can use the same formula. You can multiply 100 with 6.25 every year, and finally you see that you get 135.38. So clearly you see that in such scenario, your return is not 7.56, but rather 6.25. If you understand it wrong, if you use wrong formula, you will have wrong assumption about your return. Let's take another example. Let's say you are running a travel company called SavariTravels.com and you provide transportation services to your customers. So let's say your customer has booked a trip with you and the place is about 1,000 kilometers. So you take the customer to that place and then you bring him back. So fuel efficiency while going to the place is about 25 kilometer per liter, and while coming back you got caught in traffic for most of part of your travel and your efficiency reduced to 16 kilometer per liter. And let's say the price of gasoline is about 90 rupees per liter. So the average fuel consumption, you'll calculate 25 plus 16 by 2, which is 20.5. So now if I have to calculate the cost of my travel, so you'll say that, okay, since it's a two-way and average efficiency is 20.5, you will multiply the distance, total distance travel, which is 2000 into 90, because that's the price of gasoline, and divide by 20.5, that's the average efficiency. So if you multiply, you will get about 8,780. So you think that 780 is your cost, is your fuel cost of this trip. But are we right? Is this correct? Let's segregate. Let's calculate our cost of travel separately. So we have 1,000 kilometers while going to the place, and your cost of taking customer to destination is 3,600. And when you're coming back, it is 1,000 into 90 by 16. So cost becomes 5,625. So if you add them together, it should be similar to what we got previously. So if you add these values together, you get 9,225. But in our earlier calculation, we got 8,780, right? So you understand that 8,780 was wrong. 9,225 is the right answer. What mistake did we make earlier? We simply added the efficiency, and instead we have to select harmonic mean. And this is the formula of harmonic mean. So if you calculate the efficiency, it is 1 by 25 plus 1 by 16, and you take average and then again you reciprocate. So it becomes 2 by the value. So your fuel efficiency in this case is 19.5. And now you apply 19.5 in the formula, you get 9,226. So if you are using wrong formula to calculate, you will be running business the wrong way, and without your knowledge, you will be making loss. Now, in this case, you are losing about 446 rupees just because you made a small calculation mistake. So yes, so mean can be arithmetic, geometric, and harmonic. When you have data like total numbers, arithmetic mean is best. But when you have ratios, percentages, use geometric mean. When you have ratio, rate, by, when you talk about fuel efficiency, it is distance traveled by fuel. In such cases, use harmonic mean. The purpose of this video was to make you understand the usage of this metric in data analysis.
We will stop here and see you in the next video.